Hi, this is AI in Agriculture and our traditional podcast called I Asked AI. And in our podcast, we are experimenting with visual technologies, visual artificial intelligence, and trying to see the level of development of these models, how they can do different tasks. And in our previous versions, we have asked AI to generate imagery for comparison of data sets and understanding how synthetic data can be helpful or in most cases it was unhelpful for training the models. And now we have a little bit revised our vision what to do with models. So currently we are asking them to do specific tasks. So with generating data sets, it's interesting, but we will continue maybe later on. But with counting and detection and doing real jobs, it's much more interesting, because then we can see how the relevant or not relevant is the result which we got from publicly available multimodal AI. So let's go to our paper, and as usual you will see it next to me. I am just using the notes to keep the order. So last time we were counting the wheat kernels, and also we were measuring them based on the width and length of each kernel. We found the average numbers, and this time we are not measuring anything, but we are counting. We're still counting, because counting is just the basic, one of the basic tasks which can be automated for better productivity of some specific process and operation. And it's one of the straightforward examples where AI technologies can bring the value. So that's why we are counting today. We are counting cells, germinated cells, and those which has not been germinated. And based on these numbers, we also found the germination rate. And germination rate is a separate big lecture. What is germination rate and why it's important for understanding the quality of seeds, and how it's important for plant nursery business. At the same time, our task for today is very small, just 3 parameters. So germinated cells, non-germinated cells, and germination rate. When we are taking the germinated cells, then we are dividing them by the number of overall cells in the tray, and this will be the percentage of germination. So this is our task for today. And as usual, we are taking our benchmark, and benchmark is PTL Pro. Here, PTL Pro. So what we are doing in PTL Pro, we have fine-tuned the model which can count the germination rate per tray. And we developed it already 2 years ago, and it's very interesting how the technologies change, bring extra opportunities for germination count, because currently we are doing not just pure count and the germination rate, we can do also the per row count. There are also opportunities for classification of the seedlings and their stages, so plenty of technological opportunities, but we will stop here. It's not about PTL Pro, it's about the accuracy of models, publicly available models, ChatGPT and all of them, Gemini and Claude and Copilot and Grok. And let's just move to that point. So regarding benchmark, we have taken the same photo, and this is the production level photo, by the way. It's one of the growers shared these photos with us, and they were just interested, is it possible to count or not? So that's why, and it's possible to use them, so I decided to demonstrate the example. So in our current, this is the result actually counted, and we have 22 non-germinated, and we have 62 germinated, and total size is 84 cells. We will remember this number because the next models will have the same task, just to count. So let's go. And the first one is ChatGPT. ChatGPT was, as usual, because it takes a little bit longer for thinking mode, 13 minutes to find the right numbers, but at least the number of cells was counted correctly. In other models, it was not. At the same time, the germinated and non-germinated cells were distinguished incorrectly, and that's why the germination rate was not right. And you know, the fact of counting germination rate was not even a question, because if the initial input like germinated and non-germinated were not correct, then no reason, no sense to do the germination rate. Then we had Gemini. This time, because last time we had some visualization of thinking process and we got some visual proof of what has been counted, this time we didn't get anything, just raw numbers, and they are incorrect, they are not right. So, and starting from the total number of cells, and additionally, just to remind that we used the same photo, we used the same prompt, and that's why we expect at least something similar, but not in the, as I mentioned again, initial number of cells was not correct, then germinated cells were not correct, and non-germinated, so basically they fail because no numbers were right. Claude, exactly the same like Gemini, and again, unfortunately, you know, and I am just confused because for example, Gemini, they discovered 72 cells, and with the same photo, with the same prompt, Claude discovered 98. So again, we don't have seen, we have never seen the what exactly was counted, but it's just a huge difference between over than 20 cells were added on top by Claude, and again, the result was not correct. Then we have Copilot. And this is the interesting thing, that Copilot also believes that the number of cells, which was 98, is correct one. However, in real life, we had 84. So we have 14 cells more, and but at least they are the same mind with Copilot is in the same level of thoughts with Claude. They are same-minded algorithms, let's say. But again, based on the initial incorrect counting, we are not even checking the accuracy of everything else, because again, applying simple technology of counting germination rate is easy, because if you have numbers, you just put them into the formula and you got the number. But if your initial numbers are not correctly segmented and your cells are not classified properly, so in comparison with other objects, then that's it. You will not just get the right result anyway. Then Grok, and I must say this is a huge progress for Grok, because on the last video when we were doing the kernel count, Grok didn't answer anything. So I was trying to ask the same like with other models, and there was kind of like answer. I even did a screenshot that it was not possible to count or something like that. So I'm so happy that now it works. So but again, the number is wrong. At least he is not refusing us as a task. So I am still very believer in his abilities to work with agriculture. So I will continue asking him different questions. So now he is on my list. But again, just how weird is the approach, because okay, even let's consider 96 cells discovered. Okay, that's fine, but then you have seen the photo, and there are like the correct germination rate is 73, so that means that not half but quite a lot of the cells are non-germinated. And in this case, Grok is showing us the just one non-germinated and 95 have seedling. So I just don't know why this number, you know, sometimes it looks like some invisible person is sitting and thinking, okay, which number shall I put? Okay, let's put 95. And this is, so logic is not very clear, because again, we don't have visual proof. And this is the point, because in our case, when we are doing this PTO, we provide each cell. So I just don't overload this presentation with extra visuals, but we have each cell extracted. So we have the rows with non-germinated and rows with germinated, and you can see even the confidence for each cell. Anyway, let's go to the results. So now we have the summary, but again, the best news is that ChatGPT is counting cells in tray. At least in this case, it was correct count. So this is the biggest win of our algorithm battle. And the next thing which is good, that there is still a hope that these results are only because the data which is the view how the germination tray looks like, it's quite a unique one, niche. So maybe there are some other models which are trained on this specific data, and they can demonstrate better results. So if you know any, please let me know in the comments. Just go to the LinkedIn and give me a comment here, or send me a direct message or whatever. It will be interesting to continue this discussion, because I think it's the end for this specific experiment. And yes, by the way, and I explain why it's important to have the access for batch counting with AI power, because it's just saving money and automation in reality, how it works. And also, I will have the live stream, the YouTube live stream. It will happen on Saturday, 14th of March. And we will specifically consider the germination count in live mode. And we will ask all these models which I mentioned. So ChatGPT, Gemini, Claude, Copilot, and Grok. I'm just not sure will I have the access to Grok, because I have the paid account. Okay, anyway, I will fix it. So we will do it in a real life mode. So join me, and we will have some AI reality show. So thank you so much for your time, and we will continue to ask AI interesting questions about agriculture. See you there.